Okay, so I'm doing a linked stack implementation. So I want a new class, stack E, add my stack to 11, finish. Isn't that nice? It gave me the bodies automatically. Isn't that beautiful? So I need to private linked node E top. And I get a red squiggly. Why is that? Because I don't happen to find that. I'll do it inside. Private E data. Node E next. You should be able to basically do this in your sleep. I mean, no, you didn't have to, because I don't want you to have to write all that text. But the idea of what is a link node, I should be able to ask you on the final, what is a link node? And you should be able to say, it's got a data, it's got a next. If it's a doubly linked node, it's got a previous. You should be able to write it without, it should be unconscious. Same thing with like, what is an array list? It's an array of type E. It could be called data, it could be called the data, it could be called storage, whatever, it doesn't matter. And then it's got a int size, right? Those things should be not necessarily memorized, but unconscious to you. You should know this stuff without really thinking. It should be known, I guess. Okay, so if the top points to the top of the stack, when is the stack empty? When top points to null. Right? So empty is top equal to null. Because if it's a pointer and there's nothing in the stack, then this pointer doesn't point at anything. If there's something in the stack, then the pointer will point to the top of the stack. So here's top. And if it points to null, then my stack is empty. If it points to a link node, then there's something in my stack. So, peak. What do you do for peak? We return.
Oh, first check the exception.
Right. So if it's empty, what do we return? We don't return anything. We throw an exception. So if empty, throw new empty stack exception. And it's a red squiggly because we need to import that exception because it's Java util. Okay, so now that we know that the stack isn't empty, peak just returns the top of the stack, right? The item at the top of the stack. Doesn't remove that item, it just tells you what's there. So top dot data. Yes?
I have a question about the linked node class because in the book they wrote it as a static nested class, but when you wrote it here you didn't use the static modifier. What does the static modifier do in the nested class?
The static modifier makes it so that there is one and only one instance of that class. Instance of the class. because a class is the class is a class. It's very self-referential. Class is a subclass of object. And so by making it static, there is only one class linked node. I can instantiate more than one of them, but there's only one class instance. If I don't make it static, there may be multiple class instances. There's still multiple instances of the class. It's a very subtle point. Yes?
We did the top for the stack for arrays.
Mm-hmm.
Top was equal to a length variable. So
Top was equal to an int.
Or, I mean,
The
top was referring to a length.
in my implementation, and this is something I want to make, I'll repeat this again and again and again and again and again. My solution is not the only way. There are an arbitrarily large ways to solve all of these problems. Many aren't good, but they can be correct. So I chose to make top 0. That's a personal preference. I don't like, for whatever reason, personally I don't really like negative numbers. So by making top -1, you're saying that the top points to the actual filled top, right? So -1 says that we don't have anything in there. My solution is I make top 0 because I don't like negative numbers, completely arbitrary. Therefore, my empty method has to be different. If you say top of the stack or whatever the variable is -1 to mean empty, your empty method has to check for that -1, right? So whatever you initialize that top integer to be, like if you say, you can even pick, I could say when I construct, I mean this is not, I don't recommend doing this. So if I said in my default constructor, top was 17. Is there anything wrong with that? Is there anything wrong with that?
It's the array's only 10.
No, there's nothing wrong.
There's nothing wrong with it because then I have to go and modify, means that it's 17, means it's empty. To peak, I don't say top -1, I say top minus 17 or 16, depending on how, or 17, and then down here, empty, that's not right, so I have to return, well, I have to change this. It's ret val equals data sub top minus 17, top minus push. Now, again, it's not that. I gotta say minus 17. Right? So that is completely legitimate. There is nothing wrong with this solution other than it's confusing. Right? I could have picked any integer for top. The more natural ones would be a -1, so it says the top is going to point to the filled top, or a 0, which is it's pointing to the next empty space. That's entirely up to you. Now, if you come across code that looks like this, you should sort of chuckle at the idiot who wrote it. But it works, it will pass all the tests, it will run. It's just confusing when you read it. And so that is not as good a solution, but it is a correct solution.
You need to have an equal string and just figure out the value of the string. And do all this
You could do anything, you can do anything you want. Now the rules sort of are is that a stacks operation should be big O of 1. Right? Big O, that should be big O of 1. So pushing should be big O of 1, and popping should be big O of 1, peaking should be big O of 1, is empty should be big O of 1, or empty. So it's not necessarily correct to say, oh, I'm going to use my array, and every time you push, I'm shifting all the things over and sticking it at 0. And then every time I pop, I got to shift everything back. That's a big O of n operation. That is not, it is a correct solution, but it's not an efficient solution. Does that make sense? So there are arbitrarily large ways of solving this problem, or any computing program. Some are better than others, but there isn't a best. You want it to be readable. You want it to be efficient. You don't want to waste space sometimes. But an array implementation tends to waste space because we have empty cells, but is less complex than in a linked implementation. But they're both valid implementations of a stack or a list or a tree or whatever. Yes?
So an array list would take up more space, but isn't it true that each linked node would cost more memory?
Each individual linked node takes one more, because you've got the E, right?
Right.
And you have the pointer to the next linked node.
Right.
But the pointer is just a reference in memory, so it's about the size. It's actually probably smaller than an E. Actually, no, it's the exact same size, right? Because that data is a reference to an E. So a linked node is basically 2 references. So there's a little bit more space if you have that second reference. Whereas the array just has E's.
Right.
Actually, references to E's, right? An array of E's is just a bunch of references. So the linked node solution is about twice as big if you don't count the E. But the E is going to be so much larger than, generally larger than the reference. So the total memory used up is greater in a linked solution if the array is full. Right? Only when the array is full. Not only. But it's pretty, if the array is half full, then I think you're about the same size. So, again, that's the beauty of programming. There's no one right way. There are better ways, there are not better ways, but so that's part of the beauty also is, if you're going to use a stack or a list or a queue, think about what you want it to do, right? Do you want fast access to the things in the list? Which would you use? Array or linked? Or both? If you want fast access to the items in the list, you want to use an array because that's a big O of 1 operation. In the linked solution, it's a big O of n operation, right? You guys start from the head and traverse to the place. If you want to minimize the size, you might take a linked implementation because you don't have wasted space, because you don't know how they decide on the initial capacity. What if they pick 10 million as their initial capacity? You only need to store 5 items, right? Your 10 million array is going to use up more memory than your linked solution for 5 items. So you get to think about which solution you want to use. And that is, again, part of the beauty of programming and understanding how the classes or how the things are implemented. You get to choose the one that works best for you.